Hello everyone. Today we are going to focus on the concept of theoretical probability, which is the first of three different probabilities that we're going to talk about. And what we want to define theoretical probability as is the probability of the measure of how likely an event will occur. All right. And what we need to look at is the two different values that we're going to be looking at. The first value is our sample space, and our sample space is the set of all possible outcomes. Whereas what's of more importance than the sample space is the probability of our favorable outcome, okay? So the theoretical probability of an event, which is denoted as PE, is the ratio of the number of favorable outcomes to the total number of outcomes. And that total number of outcomes is our sample space, okay? So let's look at how we would use theoretical probability. And the first thing we're going to look at is simple events. So that's the probability of one event happening, okay? So we've got a jar, and it contains 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? So the first thing you're going to want to do is determine your sample space. And in this case, your sample space is the total number of outcomes, which is 60. There's 60 total marbles in this jar. Now, our favorable outcome is selecting a red one, which there's 32 of. Okay, so our favorable outcome is red, so that's 32. So when asked to find this probability, it would be 32 divided by 60, which can be simplified down into 8/15. And you're going to leave it in fraction form for now. We are not converting it into decimal form. All right, number 2, a letter in the word restoration is randomly selected. What is the probability of selecting a vowel? All right, so the first thing we have to determine is our sample space. Okay, how many total letters are in the word restoration? Well, there's 11. Now, our favorable outcome is a vowel. So how many different vowels are there? Well, there's 5 total. So our probability is going to be 5/11. All right, let's look at number 3 together. A day in the month of January is randomly selected. What is the probability of selecting a prime number? Now, very important, we need to make sure that we remember what the definition of prime is. And prime is a number in which the only factors are 1 and itself. So we need to think about this. The first thing we need to identify is our sample space. And in the month of January, there are 31 total days. So our sample space is 31. So now we need to figure out the prime numbers. Well, if you go through the calendar and you look at all the numbers, there are 11 total prime numbers from 1 to 31. And so our probability is going to be 11/31. Alrighty, so you are going to do number 4, 5, and 6 on your own in this video. Alrighty, so the first thing we have to do is we have to determine the sample space here for number 4. So let's look at number 4. 2 dice are rolled. What is the probability that the sum of the 2 dice on the next roll is at least 9? All right, so we have to think about all the different possibilities, all right, that can happen here. All right, all the different sums that can occur. And that means there are 36 total 36 total that will give us a sum when adding the different sides. So 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, 1 plus 5, 1 plus 6. That's 6 choices, okay, per side of the first dice. So there's 36 total. Now, what is the probability or the favorable outcome that it's at least 9? So it's 9 or higher. Well, that favorable outcome, there's 10 different ways that you can get that. So it's 10 of 36, which would simplify into 5/18. All right, for number 5, what is the probability of drawing a heart or a club from a standard deck of cards? So a standard deck of cards has 52 total cards. Now, our favorable outcome is a heart or a club. Well, there's 13 of each, so that means we would have a favorable outcome of 26. So 26 of 52, which is 1/2. All right, for number 6, there are 8 books lettered A through H on the shelf. If Scott randomly chooses 2 books, what is the probability that he chose books A and B? Now, this is a tricky one. All right, because this is an example in which the sample space is a combination. All right, the sample space is a combination. We are trying to pick 2 of our 8. Okay, 2 of our 8. The order doesn't matter, so there's 28 different options here. All right, and the key word that tells you that you have a combination or permutation is the and here. All right, is the and here. And so our answer here for this probability would be 1 of 28. Okay, so now that we've introduced theoretical probability, we need to talk about something known as the complement of an event. And the complement of an event is the probability of the event not happening. It's the probability of the event not happening. Since the sum of all probabilities in a sample space is 1, the probability of an event not happening, and that's what this negative E is 1 minus the probability of the event happening. All right, 1 minus the probability of the event happening. So let's look at number 7. The probability that it will snow tomorrow is 7/20. What is the probability that it will not snow? 1 minus 7/20, which will give us 13/20 as the probability. All right, let's look at number 8. A month of the year is randomly selected. What is the probability of getting a month that does not begin with the letter A? So we want the probability of picking a month that begins with A, which is April and August. So 2 out of 12 start with the letter A. So the probability of it not happening is 1 minus 2/12, which is 10/12, which can be simplified into 5/6. All right, I would like you to do number 9 and 10 on your own now. Okay, let's review these 2. For number 9, if the spinner to the left is spun, find the probability that it lands on a number that is not prime. So the key thing is that the probability that it is prime is our P of E. So let's highlight the prime numbers. 1, 2, 3, 5, 7, 11, 13, and that's it. So 1, 2, 3, 4, 5, 6, 7. So 7 of 16 is prime. So the probability of it not being prime is 1 minus 7/16, which is 9/16 as your final answer. All right, let's look at number 10. 2 dice are rolled. What is the probability of not getting doubles? 2 dice are rolled. What is the probability of not getting doubles? So we know, all right, that getting doubles is 6 out of 36. All right, there's 36 different options because there's 6 in the first dice and 6 in the second dice. So we're going to multiply that. 6 times 6 is 36. And then getting doubles can happen 6 times. 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. So the probability of not getting doubles is 1 minus 636, which is 3036, which equals 5/6. All right, now this has all been about simple events. So one event is happening. Now we need to talk about compound events. And compound events is the probability of 2 or more simple events happening at the same time. And there's 2 different types of compound events. There's independent events and dependent events. Independent events is when the outcome of one event does not affect the outcome of another event. To find that probability, it is the probability of the first event times the probability of the second event. Now, if you have a dependent event in which the outcome of one event does affect the outcome of another event, then to find the probability of that compound event, it's going to be the probability of A times the probability of B after A occurred. All right? So let's first look at examples of independent events. A die is rolled 3 times. What is the probability of getting ones on each roll? So it doesn't matter, all right, whether you get 1 on the first roll to determine whether you can get 1 on the second roll and you can get 1 on the third roll. These are independent events, okay? It doesn't matter. So the probability of getting 1 on the first roll is 1/6. On the second roll is 1/6, and on the third roll is 1/6. So 1/216th is the probability. All right, let's look at another example of an independent event. A coin is tossed, then a day of the week is selected. What is the probability of getting tails, then a day starting with the letter 7? It doesn't matter what the coin toss is on picking a day of a week. These are completely independent events. So the probability of getting a tail is 1/2, and the probability of getting or of picking a day starting with the letter T is 2/7. So that compound event probability is 1/7. Now I'd like you to do the next 4 on your own. And I want to focus on something in the explanation of this. A bag contains 8 red crayons, 14 purple crayons, 6 yellow crayons, and 4 green crayons. A crayon is selected, replaced, and then another is selected. The reason this is an example of an independent event is that replaced component, okay? You're putting the crayon back, meaning that the total number of crayons has not changed, okay, for each pick. All right, so I would like you to do 13, 14, 15, and 16 on your own now. Okay, so let's go through 2 of these together. So the first one I'm going to go through is number 13. So what's the probability of purple then yellow? So the probability of picking a purple crayon is going to be 14 over the total amount of crayons, which is 32. And then you put back in that purple crayon, And what's the probability of picking a yellow? And that's 6 out of 32. So you multiply those two together and you get 21 out of 256. Now, let's look at number 15, the probability of 2 purples. All right, so here it would be 14 out of 32 times 14 out of 32. And you would get 49 out of 256. All right, now once again, the key thing is that these were independent events because you replaced the crayon. Now let's talk about an example of a dependent event. So we're using the same example as above, except in this case, the crayon is not replaced. The crayon is not replaced. So just as a reminder, there's 8 red, 14 purple, 6 yellow, and 4 green. Now, how does not replacing it change this to a dependent event? Well, if we pick a yellow, all right, a yellow is going to be 6 out of 32. But because we're not putting the yellow back, there's only 31 total crayons in the second choice. And so then it would be 8 over 31. And your answer, once simplifying, would become 3 out of 32. And this is really, really important, okay? That by not replacing that crayon, our total number, our sample space has decreased by 1. All right, let's also do number 21 together. A card is drawn from a standard deck, not replaced, and another is drawn. What is the probability of choosing a heart and then a spade? So the probability of choosing a heart is going to be 13 out of 52. Because we didn't replace it, our sample space has decreased to 51, which means that the probability of picking a spade will be 13 out of 51. And we would get a final answer of 13 out of 304. This is really, really important. Not 304, I'm sorry, 204. So that replacement or not replacement will determine whether it's a dependent or independent event. I would like you to do the next 4 on your own, 18, 19, 20, and 22. Have a great day, everyone.